Hi guys, welcome to the day 2 of 100 days machine learning and deep learning crash course. In this session we are going to be familiar with probability theory and in general probability. But at first I like to answer some of the comments you made for day 1. Let me see that. What are them? There is a lot of background noise. Okay, actually my microphone is not very professional, so sorry for that. I try to reduce the background noise as much as possible, but yeah. Okay. Okay, thanks. Is there a platform for daily conversation? Yeah, you could join us on Fridays on the Slack channel, and yeah, you can find its link on day 1 or in this video. At the first of this video you can find its link and join us on Fridays. Python yet. Okay, don't worry about confusing too much, but as we go on you will understand why we introduce these maybe mathematical things, or it will be more clear for you in the in the next sessions. And about the Python, again, don't worry, we will as we go on we will include the Python codes in our sessions more, so when we get to the points, for example, we want to learn SVM or something like that, we use the Python code to get the meaning of the SVM and to use them in Python. So don't worry. Now, because our work is more theoretical and our purpose is just more understanding the frame behind the machine learning, we should know the theory and not very much the Python code. So don't worry about it. Okay, so the question is that why we should study probability. The answer is that in machine learning data we have lots of uncertainty, and we want to analyze this kind of uncertainty. Why we have uncertainty in machine learning data? Maybe it has two reasons. For example, the data maybe they have some noise in the data, so it has some uncertainty, and also we cannot see all the data, so our data set size is finite, and so we don't know exactly what is the exact configuration of data set, because we just have a finite samples of that data set. So we study probability theory in order to analyze and quantify this uncertainty and learn a framework, a consistent framework to analyze machine learning problems and making decisions based on this probability theory. Okay. So we want to get familiar with the basics of probability in this session. We start with an example and tell our principles of probability with these examples, which is very simple example. Let's say you have two different boxes. Oh, yeah. One of them is red and one of them is blue. Then let's say we have some fruits in each of them. In the first one we have six oranges. I show them with O, and 2 apples. And in the second one we have 3 apples and 1 orange. Now we actually randomly select a box, and then from that box we randomly select a fruit from that box. Let's say we choose the red box with the probability of 40%. So we choose this blue box with the probability of 60%, because if we don't choose this red box, we should choose that box. So if this is 40%, it is 60%, because the sum of them should be 100%, right? And we select the fruits equally, with equal probability. When we select each of the box, we just randomly pick one of these fruits with equal probability. Now we want to introduce and getting familiar with some symbols. We can show, we know that maybe we choose this box, red box, or the blue box, and so we have some kind of randomness in choosing the box. We can show this with a random variable. We called it random variable, and we could show that in this case with B, okay, which is a box. And this has 2 possibilities. It could be red or it could be blue. Also, for the fruit identity, which could be apples or oranges, we also could show that with a random variable, for example f, and it could be apples. Let's show that with A, and or it could be orange with O. So these are random variables. Okay, a random variable is a thing that can take some events. Okay, if we call these events. It is very simple. How should we define the probability itself? Probability. The first definition of probability, we call this definition the classical definition, because we have some different definitions of probability. We will see the different definitions maybe later, but this is the classical or frequentist interpretation of probability. In this case, the definition of probability is that the number of events occurred divided by total number of trials. And you should have very large number of trials. In other words, the number of trials should goes to infinity in order to get the probability. So if you say that I have a coin and then I want to know the probability of the head, you should toss your coin for many 100 times, or let's say 1,000,000 times, and if your coin is fair, then the probability of coin to be head is equal to is probably in the half of the events, in the half of the trials, it will be head. So it is 100 millions, 1 millions divided by 2 over 1 million, which is 1 over 2. So you will say that, okay, the chance of having head in a fair coin based on the frequentist definition is 50%. Okay? Okay. Let's move on our example. Now we could write this in a better way, mathematically. We could write the probability of the random variable, the chosen box, is equal to the red box. I told you this is 40%, so it is 4 divided by 10, and the probability of the box being blue is actually 60%, which is 6 over 10, and as you could see, the sum of these are 1. Now we say that two events are mutually exclusive if they include all possible events. What does that mean? Let me write that. If they include all possible events. For example, when I want to choose a box, I have two events. It could be blue or it could be red. So these two events together contain all possible events for B. So they are mutually exclusive. Okay? I know that maybe you have the question, or is this really necessary for learning machine learning and this kind of things? And the answer is actually yes. We will see that in interpreting the Bayesian theorem, or creating naive-based classifier. For understanding them, you should know about the probability and information theory. So yeah, just move on and don't worry about them. Okay, by this definition, we know that the probability is between 0 and 1. It's obvious. And maybe we ask some questions from ourselves. For example, what is the overall probability that the selection that in a selection we pick an apple? So we want to have the probability of selected fruit being an apple. Or if a selected fruit, if we selected a fruit and it is orange, okay, what is the probability that it has been chosen from the red box, okay, or blue box? What is the probability of this? And we want to calculate this probability. So we should learn a framework to work with that. For answering this question, we should actually learn two very important rules in probability. They are sum rule and product rule. Which enable us to solving this problem. For deriving this, we should go on step by step. Let's say we have a more general case. We have two random variable x and y, and we want to derive the probability of x equal to xi and y. This is the random variables are oftenly denoted by capital letter. So this is x is a random variable and this is an event. Okay. And y is equal to yj is, let us say this. In other words, if we draw the random variable possibilities and events, maybe we have something like this. That this is the desired event, in which this actually rows for, they are for random variable y, and these columns are for random variable x. And so in here we have y is equal to yj, and in here we have x equal to xi. So this is the number of desired events, and let's say the sum of all these is ci, and the sum of all these is rj. So we know that the ci is equal to the sum of over j in this column actually. So we could write ci is equal to sum over j and ij. Okay, means that the sum of over this one and this one and this one, it is ci. Okay, and we know that the probability of x equal to xi is ci over n, because for if we want to know the event of x equal to xi, we have some different events. In the first, maybe y is equal to y1 or y2 or y3. In all of these cases, x is equal to xi. Okay, so the sum of all these is ci, and so the probability is ci over n. Okay, in other words, we could say that, okay, and we could say that, okay, this is the probability of x equal to xi, and y is equal to yj and sum over j. Okay, so actually we say that if you want to have x equal to xi, we just can get sum over the joint, we call this joint probability, over the joint probability of x equal to xi and y have different values in here, and getting the sum over y to getting the this probability. Okay, we call this actually sum rule. So let me write it here in more clean way. And so this is sum rule. And sometimes we call this marginal probability because actually these are the margins. Okay, if you want to get the margins, we just sum, we get the sum over columns or rows, and we say that okay, this is marginal probability, because in here we have joint probabilities in these cells, and so this is marginal probability. Okay, let's say we know that x is equal to xi, and we want to know, okay, what is the probability of y is equal to yj. In this case we call it conditional probability, and it is denoted in this way, that the probability of y is equal to yj given x is equal to xi. So when we say that we given x is equal to xi, means that we know that we are in here. Okay, because in here we have x equal to xi, so we know that this is ci, and in the denominator we have this cell. Okay, because in this cell we have y is equal to yj, so it is nij. Okay, so this is conditional probability, and if we want to relate this with other equation, we could say that okay, if we want to have this probability x is equal to xi and y is equal to yj, it is, we know that it is nij over n. Let's write this in this way. Okay, we just divided by ci and multiplied it by ci. Now this is the conditional probability and this is the probability of x equal to xi, right? So it is very important in probability that if you want to get the joint probability, you could write it based on conditional probability. Okay, so it is the conditional probability of y is equal to yj given x is equal to xi times the probability of x equal to xi. We call it product rule. So in a short, if you want to say that now we both know the sum rule and product rule, Now, just one other important rule is Bayesian rule, which we can obtain it very easily. Let's say we have conditional probability of y given x. We know that it is equal to joint probability over px. This is, yeah, for deriving this you should actually divide it both sides by px, and then you derive this. Okay, so in here you could also write px given y is equal to pyx divided by py. We know that this is the pyx is equal to pxy, so instead of pxy we could write py times pxy in here. If we substitute that, we could derive it is px given y times py over px, and this is the Bayes theorem, which plays very important role in machine learning. We will see that for decision making we will use this rule. Okay, now, and also you know that we could expand this px based on the sum rule, okay, based on this rule, so you could expand it. Let's go back to our example to have a better intuition about these rules. Okay, we know that, okay, what is the probability of fruit being apple given the box is red? So we know that, where is the box? So we know that the box is red, and we want to know the probability of fruit being apple. Okay, so we have two apples in here and 6 oranges, so we know the probability of selected fruit in this box being apple is 2 over 2 plus 6, so it is 1. So it is 2 over 8 is equal to 1 over 4. Okay, now we want to answer this question. Actually, one of our answer was, what is the probability of a selected fruit, for example, being apple? So we want to know what is the probability of the selected fruit being apple. We could expand it with conditional probability. We could write it in this way. It is the probability of fruit being apple given the box is red times the box is red plus the probability of fruit being apple given box is blue times the probability of the box is blue. So you have all of these probabilities very easily, and you could derive that it is 11 over 20. Okay, now you could easily say that, okay, so what is the probability of fruit being orange? It is 1 minus probability fruit being apple, so it is 9 over 20. Okay, and another question was that, okay, if the fruit is orange, what is the probability of the box being red, for example? So we want the probability of box being red given we know that the fruit is orange. Okay, we could, in this case we cannot calculate this directly, but we could use Bayes' theorem to convert it to a form that we can calculate all of them. We could write it in this way, that it is equal to the probability of fruit being orange given box is red times probability of box being red divided by fruit is orange. Okay, so you can easily calculate this because you have P of fruit being orange. We have this one, it is 40% or 4/10, and we have this. Okay, it is actually, in the red box we had 6 oranges and 2 apples, so the P of fruit is orange given box is red is 6/8. Okay, so you have all of this, and you could calculate this term now. And if you have independent events and independent random variables, in other words, you could separate the terms. If you have P of x, y, P of x and y, the joint probability of these two, if the x and y are independent, we could write this in this way: P of x times py. This is the definition of two random variables are independent. In this way, if we have two independent events and write the conditional probability y given x, we could write it in this way, and from the independentness of x and y, we have this is equal to py. So if we have two independent variables, this conditional probability y given x, this x does not give us any new information, so this probability is equal to P of y itself, because the x and y are independent, and so this, if we know that the x has some values, it does not have anything to do with y, because x and y are independent. So okay, let's move on. Now we want to extend our knowledge into the continuous form. In the continuous form, you can say that the x, which is the random variable, could have different values. Let me say x could have different values of x, and if this capital X, which is our random variable, is between x and x plus delta x, this is actually, we could write this with the multiplication of delta x and a function of, we call it density function of x. This is the probability of this x be in this interval. So we could see that as a density function. Okay, this is a density function. This is P of x and this is x, and we want to know the probability of x in this region. Okay, and this is a p of x, so the probability is actually this area, which is px times delta x. Okay, and we have two conditions of on the density functions. The first one is that they should always be greater than 0, and the second condition is that the integration from minus infinity to infinity should be 1. Why? Because in this example, the integration from minus infinity to infinity is equal to the integration from here, and we know that it is like the discrete situation. We know that the sum over all possible events is 1. So the same things in the continuous case, we have the integration for all possible events, means that all of these have the surface area of 1. So this is two conditions that the density function should satisfy actually. Now, if we have a function of random variable, let's say we have x is equal to g of y, which is y is a random variable, and we want to know the density function of y. Okay, so we know the density function of x. For example, let's say in Python or with NumPy you produced some random samples from the Gaussian distribution or from uniform distribution, and you have another function that, for example, is equal to e to this function, and you want to know the distribution of this y. In this case, you could derive that very straightforward. I don't want to prove it, but the proof is very straightforward. But you should just calculate the derivative of this g of x and put it in here to calculate the density function of y. Okay, and we have another thing, we call it cumulative distribution factor, or CDF. It is the probability of z is less than z, and you could say that it is equal if you have z in here and you want to know the probability of z in this area. You should just need to integrate from minus infinity to z of the density function, right? And for density functions, the Bayes rule and the sum and product rule applied on all of this. For example, for sum rule, we could have px is equal to the integration instead of actually having the discrete form in here. We have integration instead of sum. We could marginalize it with y. Okay. or we have for the joint distribution we have P y given x times px. Okay, now this is the basics of the probability. We have some more definitions from the probability theory. In the probability theory, one thing which is very important is weighted average of a random variable. Weighted average. And this weighted average is by probability density function. We call it expectation of f, expectation of f, and denoted it in this way. And it is defined in the discrete case. We could say that it is defined by the probability of x is equal to x times f of x, and in the continuous form, when we have continuous random variable, this is just the integration of px times f of x dx. Okay, and sometimes we actually approximate that if we have some samples from the distribution with taking the average over our samples. Okay, and this is actually that probably you are familiar with this already. And for example, if you have 3 students and or let's say 10 students, and you know that the probability of for each student that get a mark between 0 and 20 is uniform, then you could calculate the expectation of the grades of the marks for the students. Okay, very easily from this. Okay, and another thing which is very important is variance of f. That is equal to the expectation of f of x minus power 2. In other words, we just get the expectation from, we subtract the expected value of x from f of x at first, and then make it a square and calculate the expectation of these things. You could calculate that it is equal to f of x squared minus expected value of f of x squared and this is for f of x. So you could easily say that maybe you want to write it for a random variable. You could say that it is equal to expected value of x squared minus the expected value of x squared. Okay, sometimes and this variance somehow gives you a measure of how that random variable have distributed. Let's say you have this distribution, this density function, and you have this density function. Okay, maybe it is not a good example. Let's just do this in this way. Okay, in this way, this distribution is very more compact than this distribution. So we expect that this distribution has larger variance than this one. Okay, so the variance gives us a measure to know that how much a distribution is wide or tightened in the space. And for both of these, probably the expected value is the same and in here. Okay, for both of these. Sometimes we have some different random variables and we want to know the relation between these two, and in this case we use covariance. If we want to know the covariance of two random variables, it is equal to get the expectation over x minus expected value of x and y minus expected value of y. Okay, you could easily calculate this, maybe not very easily by hand, but if you have Python, if you use Python or NumPy, you could easily calculate that. I think for this session it is enough. I hope that you actually were getting familiar with the basics of probability. We have another session on probability, but also I try to give you some examples in the Python and write for you some codes in the Python to getting familiar to how to use these concepts in Python, or if you want to plot the distribution, what should you do, and yeah, stuffs like that in Python. Maybe I know that maybe this theory at first seems very boring or confusing, but as I mentioned, if you want to have a very deep understanding of machine learning algorithms and apply them suitable and properly in the applications, you should have very good understanding of the theory and the basics of that. So yeah, I hope that you getting along with this situation and be able to handle this. Hope to see you in the next session. Bye.